Okay, we've got the Tektronix TDS680 or 680C. It's a 1 gigahertz bandwidth scope. It's in good working order. However, there's a serious problem with it, and that is the non-volatile RAMs that are used to store the setups and stuff in the software of the scope are over 20 years old. That means they're on borrowed time. This scope could fail literally any time at all. As a matter of fact, while I'm standing here, it could have failed. So what I'm going to do is I'm going to go through the procedure of removing the non-volatile RAMs, reading the contents of them and saving it, and then getting brand new non-volatile RAMs. They're available yet. You can buy them. And these are not worn out. The new ones are fresh. They have fresh batteries in them. They're good for another 10 years and typically 15 to 20 years. So this scope, once I replace the RAMs, will be good till I croak. You know? All right. So another thing, let's see. It's got a sticker on it, and I can't tell whether it's been broken or not. I don't think anybody's been in it, but they may have. Okay, so first thing we've got to do is pull the cover off of it. I've got the Torx. It takes these Torx okie doke. And I need a driver for that, which is a 1/4 inch. Okay, now we've got to pull wow, somebody tightened the hell out of those. It's rumored that you cannot remove these RAMs from the scope without having them self-erase. Now, I'm not sure that's accurate. I'll go through all the procedures I can to keep everything from having static discharge and stuff like that. The only thing I can see that would cause them to erase is if there was a static discharge, you know, not enough to destroy the unit, but enough to simply bias the chip into on state and then give it a write pulse, which would write to some random place in there and might be something important. Just pulls. Ooh, there we go. That's easy as pie. It's coming. It's coming off of there. Okay. There we go. Got it. Okay. These two right here are the culprits. Okay. Okay, we've got the time chip is 9913 and the RAM is 9810. 98 to 2018, 19, 20, 21, 22, 23, 24. So it's 10, 11, 12, 13, 14, 15, so 17 years. 17 years old. So they're guaranteed for 10 years, and the typical is 15, and that means that we're at least 2 years past the typical life. Okay, to get these out of here, we've got to go ahead and okay, all of these connectors have to come loose, because this board we have to get to the bottom side so we can unsolder the guts. Okay, first, that comes off of there. Okay, and there. Alrighty. There's that. Okie-doke. Okay, that one. We don't have any in here. I don't know what that one's for, but we don't have one, so we don't have to worry about it. Okay, here, another one. Okie-doke. Another one here. What you do is you take a small screwdriver with about an 1/8" blade, and there's the alignment thingy there, and you slip that down in that crack and you twist, and that just presses the connector out. Okay. Then the fan. Now the fan has a little retainer. You pull up on it, push down. Let's see, push down on it. You push down on it, and that pops that retainer out, and that removes the fan. Okay. Then we've got one more here. Okay, that one pops right out. Now, this one is our display connector. Okay, that is a ribbon connector. Be very careful with it. Put the screwdriver under the edge and pry up very carefully. Okay. You screw that connector, and then you've got real problems. You'll have to find another board. Okay, that gets all of our connectors to the board loose. All right. Now, when you're working with it, before you touch anything, just take your hand and press it against the chassis, and this will discharge any static that you have on your body. It's not likely. Today's a really humid day, so it's not likely to have any static, but you can still you want to do it just to be sure. All right, to get the board out, we loosen the 2 screws on here, and that gets rid of the retaining, and then we can slide the board back and lift it out. Okay, so I gotta have that Torx again. Okie doke. All right, now that will slip right out of there. We just pull that board out. It's the parallel port connector, the serial port connector board. Okay, now that leaves the board. It should be just sitting in there, and we can pry it back. And these supports for the board have cutouts in them so that it'll then come loose. So you just go back. I don't know what, oh, it's that thing. Okay. And there's our board. Okay. Now, keep your fingers, when you're handling the board, keep your fingers touching everything so that static discharge does not go to one point. The thing that'll blow it up if you have static on your hand is if you have static and you touch something, it goes through that one point and blows up the chip. If you keep your hand touching all of the points, then that keeps you discharged, the board and you are at the same potential, so you have no problem. Okay, we're done with this. All right, these two right here are the ones we have to remove, and we'll go after them using all right, now, okay, now I've got the big desoldering machine warming up. And I'm going to go ahead and use this to start with. Now, notice that I've got the iron itself connected with a grounding wire onto the ground of the board. So we have no potential difference between the solder tip and the board itself, because that's one of our major causes of having electrostatic discharge. You got to have everything grounded together, or else you can blow stuff up. All right, let's start desoldering wires here. Okay, that looks good. Okay. That ain't good. I don't want to fuck this up. Okay. I got 3 wires undone, okay? 30 to go. 40, whatever. Okay, I want to do this without. Okay. Now, what you do, you hold the tip of the soldering iron against the pin, and you move back and forth just a little bit until you see the pin move back and forth with the iron. That lets you know it's unsoldered all the way through. Okay, it's moving. All right. See, if the pin doesn't move when you wiggle that iron back and forth, then it means it's still soldered down inside the hole. Okay. Tektronix does not approve of this. Tektronix wanted you to go buy a new scope when these rams wore out. Okay, that one there we might not be able to get. I'll have to get all the rest of them loose and then heat the pin when we're pulling the thing out of the hole. This is the one that gets soldered to the ground plane. Actually, it's the power plane in this case. It's not doing. It is not doing. Okay, let's go the other side. All right, now here we're going to have trouble. This is the ground. That ain't going to come out of there. Okay, now, next thing that has to be done, we take a pair of tweezers and we wiggle each pin. Okay, connect our ground onto it, and we have to take each pin and wiggle it. Good. 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 Okay, that one does not wiggle. Pin number 5. Nope. If the pin does not wiggle freely, you don't have it fully unsoldered. So go back and do it again. Careful. Okay. All right. Okay. Good. Cat. Okay, we got that one and that one that are screwed up. I got one more here. Good. It's that one right there. Okay. Boy, that sure sucked a bunch out of there. It should have got it. That's good. All right. Now, That gets all except the two corner pins that go to the power and the ground plane. Now what I'm going to do, I need a piece of wood. Find what I did with it. Use this piece here. I've got to prop it up. Okay. Now, this in here. Okie doke. All right, so what I have to do, I've got to get the screwdriver under here, and I've got to heat that corner pin. See, what I got to do is pry on it and heat that pin in the corner, and that'll pop that end out. But I have to only pop it out a little bit. Boy. Bam! Okay, what if I do it vertically? Okay, I've got to have the ground on there. I can't. Okay. 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 All right, now I'm going to heat that one right there. I'm going to need some solder. I don't feel. Okay. All right. Okay, one side of it is lifted up. Now I've got to do the same thing on the other side. Okay. Over here. Okay. She is. All the pins are still on it. All right, now what we have to do is take a piece of wire, and we heat it and go through there, and that'll take the solder out. Okay. Okay, now what I'm going to do is I'm going to heat the wire up and push it through the hole. See, that wire moves. Okay. Okay. That one's empty. Now we got one up here. Got to do the same basic thing too. All right, let's just go with a wire to start with and see if that takes it out. Okay, that gets us one of them out successfully. All right, one more to go. Okay, we've got a gold one right here. Okay, that's a gold-plated one. Okay, that'll do. Okay, I'm going to use the one turret socket. We'll put the turret socket for the RAM and the pinch socket for the clock. Okay, I've got to cut the socket to the length of the chip. Okay, both of these are the same length. Okay, so we have to go 4 pins. I got to cut 4 pins off of each one. Okay, so I'm going to go ahead and I'm going to okay, and that is okay. Okay. Now we're shy. Okay, I got to cut 1 more pin off of each one of these. Okay. All right, that gives us a socket. Okay. Now, the little, okay, the cutout goes towards this end. Okay. Oh boy. Alrighty. Now I need to put a piece of wood under here to hold it. In there? No. Okay, tell you what. Let me get a piece of tape. All right. That's got it. All right. Now, we take that and we solder it in. All right. Okay. Cat, what are you doing down there, Cat? Okay, now, okay, this one I've got to cut too. We got to cut. Okay, we got about 4 of them off of there. Now, this one is made in such a way that I can't cut it with the pliers, so I'll have to go out and cut it on the bandsaw. All right, we got our next socket cut off. Now, this type of socket has flexible pins, so when you plug it in, make absolutely certain none of the pins folds under. That would be a total disaster. Now, we look at every one of them. Okay. Every pin is there. Make sure to warm it up enough to let it heat all the way through. You want to fill that entire through-hole plating with solder. Damn. All right. Okay. that gets our board. Oh, very, very, very good. Now, next thing you do is you take a magnifier and you look at each set of adjacent pins and make sure you don't have any solder splashes. Okay, one solder splash, that's got it. All right, that's got our board stripped down. Okie dokie. Okay. Okay. I don't know. A little bitty thing. You know, it's about $50 or something like that. eBay. Alright, let's see if this thing will fire up. XG Geekit XG Pro. I think this is it right here. Ah, okie doke. Okay. Okay, I need to set this select IC. Okay, Dallas Semiconductor. Okay, we don't need that. Dallas. Okay, we want a DS1250Y. Okay, DS1250Y. Okay, got it. Okay, now, read. Okay. Okay, location in the socket. Okay, we take that and goes there. Okay, now we got it put in the socket and blip. Okie doke. Uh-oh, that cat again. Okay, we got a bunch of zeros. Okay, let's see. Don't know. I have no idea where the stuff is. Ooh. Can't read that. This has got the weirdest damn... Either everything's reading 55, which means disaster. Ah! All right. Okay. Okay, so it's got a little funny figure. Okay. All right, here we are. Here we are. I don't know what's in here. The people that had the scope before me could have saved some waveforms and stuff like that, so I don't know what's in here. But clearly, it's full of data. Usually, if they fail in big blocks. But they can be, a single bit can fail. Okay? All right, now, let's see. Save. Okay, binary, okay. Okay, and we're going to call this, okay, I want to delete. Okay. And we go TDS680 RAM. RAM. Okay. And okay. All right, now that is that. Okie doke. Okie doke. Okie doke. It had all the numbers. It contacted. It's a decent socket. It's good quality socket there. This one fucked. Okay, so what we're going to do is we're going to take the brand new ROM. I've got the brand new one here. It's got a date code of 2019, and that'll be good for, guaranteed till 2029, and probably will be good for another 5 years after that. So it'll be well in the future. Okay, first thing I'm going to do, I'm going to take the old RAM, whatever you call it, and I'm going to read the data into the computer, and I'm going to write down a few locations, and then that will make it to where we can look at the new ROM and see if the locations are identical. Because if they're offset or not the same, then we've got big problems that'll have to be solved. Okie doke. Let's see, we need to all right. Now we need to okay, we don't need that. Okay. The program remembers the last item that you were using, so we're already set up in here. So what I'm going to do is I'm going to read it. Read. Okay, we take it and okay, put it in the socket. And Okey-doke. Go down here. Click. He's reading it. Blink. Okay. All right. And that's our stuff. Now I'm going to take it and I'm going to go down and get to the code. Okay. Okay. All right. I've got location 10000. Okay, and I'm going to write down the code that's in that location. Okay. B000. Okay, that's good enough. What we'll do is we will load the program into the new ROM, then we'll read the new ROM, and we'll check that location and see that this string of code is there. Okay, if it is, success. If it's not, then eh. Okay. All right, put the old one away and we get the new one. Okay, all right, we take that and it's in the socket. Okay, we go up here to program. Okay, program. Okay, plug it in and blap. Okie doke. Okay, 20.02.88 000000 B0 004082. It's in the right place and it looks good. All right, so we have a brand new ROM with the software copied into it. We've got this also in the stored file. Okay, what I'm going to do is I'm going to, let's see, okie doke. I put my hand on the metal before I touch the board, get rid of any static. Okay, now this goes like this. Second level. Okay, there we go. Now it looks flat across. Hey, now, okay, let me check this first. Oh, yeah. Okay. It doesn't jam. Right in. Now this All right. Okay, that takes care of those. This one here, we don't really need it, but we'll put it on there anyway. Okay, and this one here, don't know what the hell that's for, but we'll put it on there. Here. All right, take it and put the okay, we're pulled up. Okay. Cook. That's in there. And then this one. I have no idea why they had to use that kind of connector there. They could have used just one of the standard cables and it would have been just fine. But hell, you can't tell what the hell Tektronix is going to do. Okay. Fan. Okay. Okay, the whole scope is together. All right, we've got two ICs. All right, I got the 1250. It goes here. Ooh, that fits right in there. Missing the other one. I knew I had it here. Okay, all the pins are straight. And this one goes here. Okay, that's it. Okay, let me get a power cord. Okey-doke. All right, here goes. Nothing. Let's see. All right. Come on, baby. Got the little clock, got relays being tested. Okay, got flashing lights. Woo! There she comes. Copyright. Self-test passed. Plus clear to go. No edges. Hey, it's there. I mean, the signal's there. Okie dokie. That's on 200 pico. That's the fastest time base there is in the scope. It's 200 picoseconds. Alrighty. Hey. Okay. So now we know that we cannot lose the scope because of the RAM, going bad, timing out, and failing. That'll last forever.